Okay, I want to solve this. So probably what I want to do first is get rid of the 2 theta. And so I know that cosine 2 theta is the same as 1 minus 2 sine squared theta. And that's supposed to equal 2 minus 2 sine squared theta. So if I do that, if I bring things over, it looks like I have 1 equals 2, which is false, so there's no solution here. Now let's look at this one. I have cosine 2 theta plus cosine 4 theta equals 0. Well, this is the same as cosine of 2 theta plus cosine squared, 2 cosine squared of 2 theta minus 1, right? Because this is the double of 2 theta, and it's also just 2 cosine squared of that minus 1. So now I have 2 cosine squared 2 theta plus cosine 2 theta minus 1 equals 0, and I can factor that as 2 cosine 2 theta minus 1 times cosine 2 theta plus 1. And that means that cosine 2 theta is 1/2, or cosine 2 theta is -1. So 2 theta equals 1/2 at, cosine is 1/2 at pi over 3, or plus 2 pi k, or 2 theta is going to equal 5 pi over 3 plus 2 pi k. And here, 2 theta is going to equal pi plus 2 pi k. I'm going to divide by 2, and I get theta is pi over 6 plus pi k, or theta equals 5 pi over 6 plus pi k. And here I have theta is pi over 2 plus pi k. So I have to do k every time. So for the first one, if k is 0, theta is pi over 6. If k is 1, theta is 7 pi over 6. Plus 6 is that. Okay, for the second one, if k is 0, theta is 5 pi over 3. If k is 1, 5 pi over 6. And if k is 1, it is 11 pi over 6. So I have all the pi over 6 covered. And now the last one, if k is 0, theta is pi over 2. And if k is 1, theta is 3 pi over 2. So my final answer is theta equals pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, pi over 2, and 3 pi over 2.